This is Algebra 1, Lesson 6.3, Solving Compound Inequalities. Right, solve, and graph compound inequalities is what we're doing, and we're going to model a real-life situation to go with it on page 346 in your text. First thing we have is what a compound inequality is. Definition of one. A compound inequality consists of two inequalities that are put together by those small little words and or. And again, the way you solve it is going to be very different depending on if it's and or if it's or. Or inequalities are typically easier for people to understand, and you have to put them together in the middle. So let's look at a few examples. Write an inequality that represents the set of numbers and graph the inequality. So the first one, all real numbers that are greater than or equal to -5. The easiest way to do this is to write them as two separate ones and then put them together. Greater than or equal to -5. So what you want to do is you want to say x and you want to say -5. So everybody write that right on top of it, just like I did. X and -5. Then you want to put a symbol in the middle to represent that. The numbers are greater than or equal to -5. That means those numbers x are going to be the bigger value. So greater than or equal to is going to look like that. The other one says and less than -2. And less than -2. So x is less than -2. And again, x and -2, the symbol goes in the middle. The smaller number is x. The big mouth or the opening is eating the bigger number, -2. Now, again, what I told you a little while ago about this being and or. This right here says and. You need to put these together. Anytime you have an and inequality, you put them together with the x in the middle. So we take this inequality that we have written on top, x is greater than or equal to -5. This inequality in red we have up here, x is less than -2, will never go in the opposite direction as this one. They'll never go opposite. This one will never go this way. It will always go the same way. So when it goes the same way, it's going to look like this. And then -2 is going to go here. And again, if you're able to read this from the middle going that direction, you can see that it says x is less than -2 because the big mouth is eating the -2. So let's take a look at that. On that number line you have there, you don't have to include all of those numbers. Just show where 0 is, and then show where -2 is and -5. Remember, anytime you have or equal to, we talked about this a long time ago, or equal to means a closed end bubble. Just less than is an open bubble. So when you graph this, the greater than one shows this way. The less than shows this way. And inequalities, and they typically overlap. They don't always overlap towards the middle, but they have an overlapping area. So the inequality is what we have written up there at the top. And notice it's written backwards of everything that we have up there, but it says the same thing. The big mouth is still eating the appropriate number. The big mouth is still eating the -2. And if you look at the other side, it's still eating the x, not the -5. And the reason it's written that way is to put the smallest number first, to where they're counting from small to big. The second one says all real numbers that are greater than or equal to 3. So here we go. Greater than or equal to 3. X is something 3. Greater than or equal to, we know, is this. Or less than -3. X is less than -3. Again, important, or. When you have an or inequality, they're written simply as two separate inequalities. So the first one is x is greater than or equal to 3. And then in the middle, you write that little word or. X is less than -3. So when we graph it, when you graph them separately, the first one, greater than or equal to, is a closed-in bubble in everything that way. The second one, x is less than -3, is an open bubble in everything that way. And when you write that inequality, notice it's written as two separate ones, the ones that I wrote up top, with the word or in the middle. X is greater than or equal to -3, or x is less than -3. I said -3 a second ago. Greater than or equal to 3, or less than -3. And the last one, C, says all real numbers that are greater than or equal to -4 and less than or equal to 0. So right here we have greater than or equal to -4. Just put x and put -4, and then decide which symbol goes in the middle. Greater than or equal to, the big mouth eats the x, or equal to means the line goes under it. And less than or equal to 0. X is something 0. Less than means the big mouth is eating a 0, or equal to means this. Again, that word and pops up. And. That means both of them together. So if we graph it, graphing it's easier for these usually because they're written the way we're going to graph them. X is greater than or equal to -4, everything that way. X is less than or equal to 0, colored in, everything that way. Notice the overlapping area. When you write this, write the smallest number first, -4. The x is in the middle, and the 0 is last. This one right here is written in the same order as this one. So x is less than or equal to that, and this one goes the same direction. They never go opposite directions. That'll be the only mistake you'll make on stuff like this. You'll be able to write x is less than or equal to 0 with no problem, but then you'll have this symbol going the other way. You'll have this one looking like this. That will never happen in these inequalities. That's impossible for an and inequality. So as long as they're going the same direction, you're at least partially right. On the back, everybody in the white area, let's do this one. You don't have to copy it down. I want you to give me that scenario as a compound inequality. All real numbers that are greater than or equal to -2 and less than 3. Write them as two separate ones and then put them together in the middle. Take about 30 seconds on that. Okay, for this one, all real numbers that are greater than or equal to -2. X is something -2. Greater than or equal to, looks like that. And less than 3. X is something 3, less than that. Again, this is the key right here, and. So put them together. And means x is going to be in the middle. So put the smallest number first, put x in the middle, and put the bigger number last. This one is in the same direction as this one. Notice x comes first, then 3. So make that symbol match. And then this one goes the same way, less than or equal to. So here is your, it goes this way. This one is your inequality to represent that scenario. Example number 2 says solve -27 is less than 5x minus 7, which is less than 18. I told you guys about this before we started. You have not only a left and a right side now you got a middle, a left, and a right. Whatever you do to one portion, you have to do to all three portions. So in the middle, you undo, you still work your order of operations the same way. You undo addition and subtraction, then you undo multiplication and division. So the first thing we do is undo -7. We have -7 here. we add 7 to undo it. So if you add 7 there, you have to add 7 to the right and add 7 to the left. When you do that, negative 7 plus 7 is negative 20. 5x is left alone, and 18 plus 7 is 25. Then to get x by itself, it says 5 times x. You divide by 5. You do it to the middle, you do it to the right and the left. Negative 20 divided by 5 is negative 4. 25 divided by 5 is 5. Notice the symbols do not reverse. You do not reverse the symbol because you are dividing by a positive 5. The fact that it comes out to be negative 4 on the left doesn't matter. You're dividing by positive 5. So the solution to this is all real numbers that are greater than negative 4, and anytime you have x in the middle like this, it'll be and less than 5. When you graph inequalities, if there's an overlapping area, it's going to be an and inequality most of the time. The graph will look like this: greater than negative 4 and less than 5. Example number 3 is typically easier. Well, let's on the back, everybody do this one. Negative 5 is less than or equal to 2x plus 3, which is less than 7. Still work your order of operations in reverse. Okay, undo the fact that it says plus 3 by subtracting it. You do it to the middle, do it to the right and the left. Negative 5 minus 3 is negative 8. 7 minus 3 is 4. This is canceled and leaves you with 2x. Ask yourself if you need to reverse the symbol or not. You don't, because all you're doing is subtracting. So this is going to stay like this, and this one will as well. The last thing you do is undo 2 times x by dividing by 2. What you do to the middle, you do to the left and the right. Negative 8 divided by 2 is negative 4. 4 divided by 2 is 2. You divide it by a positive 2. So again, you do not reverse the symbol. It's not or equal to on the right, excuse me. It's just less than, and this one is or equal to. So negative 4 is less than or equal to x, which is less than 2.